Hello, my name is Valentina. I'm working on assessment of time completion of computational experiment in Desktop Grid. I'll tell you about dynamic forecasting of the completion time of a computational experiment in a Desktop Grid. To perform high throughput computations and process large massive data, usually use supercomputers or computation clusters, but we're developing channels of internet communication, increasing productivity of PCs, are more popular as Desktop Grid. It's a grid system that includes non-specialized computation. They use the time for free computational resource for making these calculations. This Desktop Grid has a number of advantages. Thanks to this system is suitable for research, high throughput calculations. And one popular platform of organizing distributed desktop grids is BOINC. BOINC as architecture client server. Key theme is a project, autonomous essence, within which calculations are done. It has a server BOINC with a task which is split to a large number of small tasks that transfer to clients and make computations, send results back to the server. Server accepts results and combines it in calculation projects for computational experiments. Computational experiment is a set of tasks for which results analysis can be started when finished. All the tasks of the computation, but due to this it's hard to assess this time. Time assessment for computation experiment is important in practical terms. We're considering distributed computation system based on Desktop Grid on a BOINC platform that includes a number of computation nodes. And computation nodes can work with interruptions and calculations. It can be increased or decreased with time. Tasks can be lost due to missing a deadline or node out of network. The computation experiment with n task we consider time based on new results, and new result has a time label. When forecasting time row, we need to determine functional dependency and describe, which is called forecast model. Assume that change in performance is linear and deviation of forecast should be minimal. After a model is determined, we calculate the forecast value and make trusted intervals. We consider a process of accumulating results retrieving. This process is described by a time series, ZGT, as is fixed in discrete time points. At the point of forecasts, one should estimate a time point at which observed value or process will exceed a specified value A. So when making forecast model, we assume the following. First, we consider as functional dependency between previous and future values of the process, random error, normal law of the distribution, dependence price-wise. As observed process presents time of getting new results, it is growing. We cannot get several results at the same point of time. There's also change in interest to Desktop Grid project, the increase or decrease productivity of computational system and the speed of retrieving results. We think that change in interest is happening linear, because non-linear could be related to project launch, also competition inside, and cannot be long term. We consider a reverse process. Why? As a statistical model, we selected a linear regression model described by the following formula: A and B coefficient of regression. It can be found by the least squares deviation method, and A and B calculation is in the third and fourth formula. When selecting the rate statistical model of mismatch of this pointed forecast and mismatch of real values with forecast could be error of parameters and random error. These errors can be shown as a forecast confidence interval. Confidence interval is an interval in which the true value fails with a certain degree of probability. Confidence interval determined in the following way. We made a number of experiments, and the results are shown as a graph. We built our process and forecast for 50 steps ahead. But while forecasting for a long, as a large error, in order to avoid it, we averaged the values. So processed one step, we got a few values. So one step, 10 values. And they were able to forecast for a longer period of steps ahead. As productivity of network changing, our process changes at some point of time, forecast stops working, and statistical error helps to find a point where we need to change the forecast. Then statistical error is a standard deviation of true values from forecasted and calculated according to the formula on the slide. As soon as error reaches a certain level, they need to recalculate forecast. We got a number of experiments, observed accumulation of statistical error, and looked for points where forecasts need to be recalculated. We present a statistical approach, batch of task runtime estimation, Desktop Grid, which consists of choosing statistical model, forecasting and construction confidence intervals, tracking statistical error accumulation, and recalculation of the forecast. Based on this described mathematical statistical models, we develop an algorithm and our planning, which is used in BOINC module. It works in test mode now, and project leaders can forecast when this experimental computation experiment is over. Thanks for your attention. Any questions? Questions? Two questions. First, if you develop a model, maybe you upload it somewhere. Yeah, it's available to project leaders in BOINC. And it's a central BOINC. Now it works in the test mode, and our colleague on which statistics we made our research, she was able to forecast the completion time. So far it's in test mode, but in the future, having updated our approach, it will be available to any project manager, this module. I mean, I thought you deployed your own grid. No, there are no questions. Thank you. One question. Do you have any results on tables, spreadsheets with forecasts, or I missed something? Well, as a result, we have these graphs that show that our model works good. So we were able to accurately forecast our process behavior.
Any more questions? Well, thank you very much. There is one more question. Good afternoon. Thank you for your report. You said that the project that tested your model, what kind of project was that, and what kind of computation? This is orthogonal and diagonal Latin squares project, and it was launched not so long ago. They had a number of tasks. Now they are finished with the tasks, and they are adding new tasks. But in general, the projects are very different. And in order to tell the exact framework of the project, you have to go inside, and you have to go to the website of this project, and at this website you can find the visualization of the results in the form of graphs. In our article we have a reference, a link to this project. Well, thank you very much. We have coffee break now, and